So I'm drawing one circuit. You should tell me what is application of the circuit. Now this I give V input, okay, and I have V output here, okay. So I have a ground here, and my input signal I'm just giving you. I'm giving an input signal of this. I'm giving input signal. This is my input signal, okay. There's a high value Vmax, so you can say plus 5 volt at the top, and a 0 volt base. Okay, the same convention you apply. Just see what you want to see. You just see the current direction and decide whether that is NPN or PNP. Okay, and when it's decided, you just see the same convention you yesterday, what you did yesterday. If N MOSFET, if input is high or signal the base is high or control terminal is high, it is on, and if it is zero, it is off. For P MOSFET, whatever. Okay, so just see this circuit for some time and tell me uh, what is the output V0 waveform. Okay, I'll just name it. This is how to name it. This is P. This is N. So this is NPN, and this is P. This is N. So this is PNP. Okay. So I name this transistor as N BJT and NPN BJT N1, and this I name it as P1. Now use the same convention that we used yesterday, and still I again remind you we are using abstracted view of transistor as a switch. Although circuit will be same exactly, but you should remember we are using abstraction of transistor. This is especially for digital circuit. What we're trying to do is we are just trying to familiar with the different operations of transistor, right? Because what I have seen in my previous experience and in my own life, when we discuss all the theory of diodes and all the clipper, clamper, rectifiers, all the things, already few 2 months or 1.5 months, then we start BJT. Then we think, oh, BJT will be very difficult. First, we understand the theory of BJT characteristics. Then we start the MOSFET and all the design. Then it becomes we really don't get into design aspect, and we fear the circuits are so complicated or something. So I plan, let's directly do some application. We directly start thinking in a diode and transistor point of view. That makes us very really confident, right? We feel like okay, we can deal with these things. We are done already. So this aspect is done in many of the subjects. We start with the black box approach. We just tell the student this is black box, this works like this, and you start doing things. You see application, you appreciate the things it's working. Then you go deeper. Then you go what is happening inside the black box. What is diode junction happening? The P type, N type, and junction is increasing, decreasing capacitance, etc. A lot of things we go after understanding. Even transistors also. If you go into deeper transistor, there is nanotechnologies, nothing but nanotechnology, and you can go more and more deep. But right now we are taking its abstracted view, top view, transistor switch, and start discussing applications, how it works, and we start thinking, we're designing something, simple circuits. Then we go deeper with more interest, right? In other, opposite case, from the bottom top approach, we may lose the interest and we may lose the thread also. We may get confused with the all the semiconductor things, equations, and all those things. So this is top bottom approach. We're taking from application to the basics. We are understanding designing things. We are understanding the applications. Then we go for the bottom part. Okay, so this is important because as a designer, as an electronics designer, analog circuit designer, you are not thinking about the science or physics of a device like diode or BJT or MOSFET. You're thinking of how it works. The designer when they do circuit design, they are considering each of the element like diode, transistor, resistor, capacitor as a black box. He know how it works, and he is not care about the internal semiconductor physics or other complicated things. Okay, and that makes life very easy also. Okay, so in order the students not to get bothered by the lot of complicated theories and all those things, we directly start with the circuits. Okay, so we start loving transistor, we start loving diodes, and we see real life applications happening in front of us. Then we can be more curious and go ahead and understand them. So I think this helps. Okay, so anyone has got how what is the output in this? Okay, some students are saying they got some waveform which is same as green. Only one student, only Vishnu got. Anyone else? Yeah, same. Kanayas also got same. Anyone? I think today. Oh, okay. 47 students are there. Okay. Same. Okay, so let's see. Same. You're right. Exactly. There's no difference. So let's see. Let's see. Starting. How where to start? You should know where to start. It is from the t equal to zero. So when we consider here, starting point is time t equal to zero. I call this is the waveform time t equal to zero. Okay, so we'll start here. What is the value at that time? Input value is zero voltage. Okay, so I'm going to draw my output waveform here. So this is going to be output waveform, and this is having a t equal to zero here, t equal to zero. Okay, okay. Now when input is zero, and now I'll draw the input, different input. Now in V equal to zero, so this zero is going to the base of the NPN as well as PNP. When the input to the NPN transistor is low, it is off or it is cut off. That means this path to VDD and output is disconnected. There is no connection between VDD and Vout. And what about PNP? Whenever input is low signal, it is on. So Vout is directly connected to the ground. So whenever input is low, my Vout is also low. You're right. Now at a point t equal to t1, t t1 whatever t1. Now my input changes to plus 5 volt. Okay, plus 5 volt. Now my input is going to be high value. So let's see what happens if the input is going high. Okay, now my input is going high value, right? That means base of the NPN is also high, PNP is also high. Okay, we know whenever a high signal or high voltage or current is going to PNP, NPN transistor, it is becoming on. That means VDD is shorted to the ground, right? And what about PNP? Base is high voltage, it is off, right? So at that time, we can see the VDD is connected to the output. So we can say the waveform is like this, and high, and all the time it is high, it remains high. And whenever input again goes low, the same action continues and it is same. Now you can see I'm getting a same voltage, same waveform like in input, exactly same timing. Maybe some distortion may be there, but this is exactly same. So my question is, so what is the need of this circuit? If my input is same as output, what is the use of this circuit? Okay, it's not audible. Satyanshu is saying it's not audible. Okay, I'll speak more in more loudly. Okay, so my question is why to use this circuit? Why this circuit is used if the input is same as output? Anyone? It act like a circuit breaker. Circuit breaker. Okay, that is a different concept, but um, maybe your idea may be same, but it's not exactly circuit. Circuit breaker is some petty device which just yeah. You one way you're saying it. It's actually you can say it's actually a buffer. What is a buffer? It's a buffer means say your signal is traveling long distance. So when something is traveling long distance, you it get tired, or when the signal loses strength, it becomes weak and weak and weak. So what happens? You keep a buffer. What is the buffer? I'll just draw. Now the circuit is clear. I'm going to change this. So for example, we have signal. A signal is going here. Okay, and initially I'm giving a voltage of how much? Plus 5 volt. Okay, input signal is plus 5 volt, plus 5 volt. This is T1, this is T2. But as it travels towards long distance, this is sending side and this is receiving side and sending. This is sending side and this is receiver side. So let's see what happens in the receiver side. Let's see the signal. You can see the signal. Receiver side signal is like this. You can see where T1 is this, T2 is like this. Can you imagine this is what we get in the transmission system? We don't get what we send. We get something distorted in everywhere, mobile signal or moreover we have some noises also. Getting and sometimes our signal or the receiver signal can be something entirely different shape also. Are you able to see? So this is what reality happening. So what happens? Why this is happening? Because there is some impedance and resistance, or some there is a resistance from this. There is resistance given by this line. Okay. So what we'll do? One option is whenever we have long wire, what we'll do? Long distance trans. We keep some buffers in between. What's buffer? We keep some buffers. This is a sign of buffer. Okay. What is the buffer? Buffer is a strengthening circuit. Whatever signal is coming, if it is high, it strengthens that signal. For example, your signal is coming. We are given 5 volt, like here. We are given 5 volt. By the time it reaches this, it is somewhat weak. It becomes weak, and after the buffer, it becomes strong again. Okay. Now you can pass to the rest of the circuit. So this is called a buffer circuit. Clear? Buffer. You can remember what is not gate. Not gate we keep with buffer. We have a bubble. We have bubble. Then it becomes not gate. Okay. Inverter. One input I get zero. With zero input I get one. Getting? So buffer is just a amplifier, kind of amplifier, right? It strengthens the signal. It amplifies the signal. It can reduce noise. Okay. So if it's traveling, your signal is traveling a long distance. So this circuit, what we had just discussed, can be uh, can be seen as a buffer. But what is the problem? It gives some delay to the signal path. Okay. But sometimes these buffers are important to give delay. You know what is delay? Yeah, two signals are reaching at one point. For example, I have a circuit like this. I have a gate like this. Some gate for example, AND gate. Okay. For AND gate, I had two inputs to the AND gate. Okay. Uh, One signal is coming from lot of things and it's coming here. Okay. I have another signal also coming from different blocks and coming to this. Okay. Both are coming. But if one is arriving fast, if one is arriving much faster, it is arriving at 10 o'clock. Sorry, I'll just take an example. It is arriving at 10 o'clock. It is arriving 10 a.m. Okay, but this is arriving 10:01 a.m. or 12 a.m. whatever. That means I have a no, I don't have some synchronization. Two signals are having distant at different times. So sometimes I want to synchronize two signals. What I'll do, I'll it's not possible to delay this signal 10.1001. I'll try to speed up it, but it's not able to speed up. What I'll do, I'll keep some delay here. Delay delay circuit in the what is the delay? I'll have to delay it by 1 minute. 1 minute delay. Getting? So what is happening in the delay? I can give delay by lot of buffers. Lot of buffers. If I have 20 buffers giving 1 second delay, I need for 1 minute, I need 20 buffers 1 second. So 60 second means 20 into